Have you ever wondered how a razor blade is made? That tiny object we use almost every day, seemingly so simple yet capable of cutting thousands of hairs in seconds without us even noticing. Behind every blade lies centuries of evolution, advances in metallurgy, and a highly precise industrial process that transforms a thin sheet of steel into a safe, durable, and perfectly sharpened tool. The act of shaving is almost as old as civilization itself. It's estimated that over 30,000 years ago, early humans began experimenting with sharp stones, seashells, and pieces of flint that functioned as rudimentary blades. They were crude objects, but they served their basic purpose, removing body hair. In ancient Egypt, shaving took on a strong symbolic value. Priests were required to present themselves hairless upon entering temples as a sign of cleanliness and spiritual purity. To achieve this, they used bronze razors which, although primitive compared to what we know today, were a great advance over sharp stones. In Greece and Rome, shaving became part of the ideal of male beauty. Free men took care to keep their bodies hairless, and a clean-shaven face became synonymous with status. Roman soldiers even shaved before going to war. They did so for practical reasons, as a long beard could be caught in combat, posing a danger. During the Middle Ages, razors became more elaborate. Blacksmiths worked with iron and later with steel, creating stronger, finer-cutting blades. However, the risk remained high. A wrong movement could cause deep cuts. Over the centuries, shaving was a ritual steeped in tradition, aesthetics, and even religion, but a truly safe and accessible instrument for everyone was still elusive. The great transformation came in the 19th century. With the emergence of barbershops, men began looking for more practical solutions than dangerous fixed-blade razors. At that time, the first detachable razors appeared, with a reusable handle and interchangeable double-edged blades. The real change came in 1901, when King Camp Gillette introduced the world to his invention, a disposable, affordable razor made of high-quality steel. The idea was simple but brilliant, a cheap, single-use product that could be replaced without sharpening. What began as a personal solution, Gillette was tired of cutting himself with traditional razors, became a global business. Its product became so popular that, within a few decades, razors were present in every home. Today, more than a century later, razor blades remain the global standard. It is estimated that 75% of men on the planet shave daily, and that, over the course of a lifetime, each person can cut up to 200 kilometers of facial hair. The basis of every razor is stainless steel, a material chosen for its strength, durability, and ability to hold an edge. This steel arrives at factories in the form of strips, which are long, thin sheets just 1/10 of a millimeter thick. To put this in perspective, a conventional sheet of paper is 0.1 millimeter thick. That is, the steel strips are almost as thin as a notebook page. Stainless steel has two fundamental qualities: rust resistance. Constant contact with water and humidity does not easily damage it. Tempering capacity. It withstands heat treatments that increase its hardness without losing flexibility. It is precisely this combination that makes it the perfect material for a tool that must be extremely thin, sharp, and at the same time, reliable. The initial die-cutting process is a process where precision is absolutely crucial. It all begins with the stainless steel strip, that extremely thin sheet that arrives at the factory in the form of long, flexible strips. These strips, although they appear fragile, are the perfect raw material for becoming a razor blade thanks to their strength and durability. The strip is inserted into a die-cutting press, a high-powered machine equipped with high-precision metal molds that function as a kind of industrial cutter. Through this system, the steel is pressed and trimmed to shape the first pieces that will gradually become blades. The result of this process is the so-called preforms, small metal cutouts that already show the basic silhouette of a razor blade, although at this stage they still lack sharpness and strength. In fact, the steel at this point is still surprisingly soft, so flexible that it can be easily bent, which is why it is often compared to metallic paper, malleable, thin, and without any real cutting ability. Although it may seem like a simple step, the initial die cutting is one of the most important in the entire production chain. Each die must be calibrated with millimeter accuracy, because any deviation at this stage would impact subsequent sharpening, polishing, or even quality control. In other words, if the initial cutout is not perfect, the entire process loses efficiency, and the final blade may not meet the safety and performance standards expected of such a delicate product. This is where the magic of metallurgy begins. The soft preforms must be transformed into hard, durable blades, capable of maintaining an edge over multiple uses. To achieve this, they undergo a 4-stage heat treatment. Extreme heating. The pieces are heated to 1100 degrees Celsius for 30 seconds. At this temperature, the steel becomes incandescent and its internal structure begins to reorganize. Rapid cooling or tempering. Immediately afterward, they are immersed in cold water. This thermal shock causes the steel to harden dramatically. Cryogenic cooling. The blades are placed in a chamber at -50 degrees Celsius for 20 seconds. This lesser-known stage stabilizes the metal's internal crystals, preventing deformation. Controlled reheating. Finally, the pieces are heated again for 20 seconds. This corrects the fragility acquired during tempering, achieving a balance between hardness and flexibility. Thanks to this process, the steel transforms from a soft sheet into a strong and durable material, ideal for maintaining extremely fine cutting edges. With the pieces already hardened, a key phase begins that combines identity and functionality. First, the brand logo is printed on each blade using a precision printer, and the ink is dried using gas flames that ensure a fast, clean and uniform finish. This is followed by one of the most delicate processes in the entire production process: grinding. The blades are inserted into a machine equipped with abrasive bases that wear down their edges with millimeter precision, transforming them into double symmetrical edges so thin they are capable of cutting a human hair without resistance. This operation transforms a simple sheet of steel into a high-precision cutting tool, but to further refine it, the blades are then polished to remove any microscopic burrs that could affect their glide over the skin. It is precisely at this point that they are separated into individual pieces, becoming for the first time actual blades, ready to continue with the final processes that will lead them to become the product we all know and love. It's not enough for a blade to be sharp, it must also be precise, uniform, and completely safe. That's why the first quality control step comes into play here. This is a crucial stage in which specialist technicians carefully check the symmetry of the edges to ensure that each edge is identical on both sides. They analyze the cutting angles with high-precision instruments that detect even the smallest deviations. They also subject the blades to inspection under fluorescent light, a technique that reveals microscopic imperfections invisible to the human eye under normal conditions. Any blade that shows irregularities, no matter how small, is immediately discarded without hesitation, because with a product that works in direct contact with the skin, there's no room for error. So only those blades that pass all these tests advance to the next stage of manufacturing, ensuring that what reaches the hands of the end user is a reliable, durable instrument with the necessary safety features to provide a clean, comfortable shave. One of the most crucial moments in blade manufacturing is the application of protective coatings, a series of processes almost invisible to the human eye, but essential to ensuring that each blade not only cuts, but does so smoothly, precisely, and without irritating the skin. First, the blades are chrome-plated in a vacuum chamber, which strengthens the edges and gives them greater resistance to daily wear and tear. Then, a lubricating layer is applied in the form of a fine spray, designed to create a silky surface that reduces friction and allows the blade to glide effortlessly. Finally, they undergo a controlled baking process at 350 degrees Celsius for 20 minutes, where the heat sets each coating into the steel and ensures its durability. The result is blades with a strong, flexible edge that stays sharp longer, while offering a more comfortable shaving experience, with less risk of irritation, and with the assurance that, behind something so simple, there is a complex protection system designed to protect both the user and the lifespan of the product. Before reaching the packaging, the blades must pass a second, demanding round of testing to ensure their true performance under conditions similar to those of everyday use. Each blade is cut through wads of wet paper, a material chosen because it mimics the strength and texture of human hair. This allows for the precise measurement of key aspects such as the depth of the cut, the force required for the edge to glide effectively, and it's to maintain its performance over several consecutive attempts. This test not only ensures that the blade is sharp, but also that it is consistently and safely sharp, as a blade that is too fragile or uneven could quickly lose its edge or cause discomfort on the skin. Therefore, only those that meet the highest quality standards advance to the next stage of the process, while any unit showing the slightest irregularity is ruthlessly discarded, ensuring that what finally reaches the user is a reliable, durable product capable of providing a close shave every time. Steel, although stainless, is not invincible. To further extend its lifespan, the blades are immersed in organic oil for half an hour. This invisible layer protects the edge from moisture and ensures that the blade maintains its properties even after months of storage. The final step in razor manufacturing is packaging, a process as important as any previous stage because it ensures that the product reaches the consumer in perfect condition. Each blade is carefully wrapped in waxed paper, a durable material that protects against moisture, prevents corrosion, and at the same time prevents the edge from dulling, ensuring that the blade retains its quality until the moment of use. These individual blades are then grouped into small packages and later into larger boxes that facilitate their transportation and global distribution, traveling from the factory to supermarkets, pharmacies, and all kinds of specialty stores in different countries, turning such a small object into a product with an enormous logistics chain. On average, each blade provides approximately 6 full shaves, although this number varies depending on the thickness of the facial hair and the user's grooming. Therefore, something as everyday as a razor blade involves not only engineering and precision, but also a protection and distribution system designed to ensure that it arrives safely, ready and functional anywhere in the world. A razor blade may seem like a tiny, simple object, but it's actually the result of a monumental process that combines centuries of evolution in the way we shave, metallurgical and chemical advances that made it possible to transform simple sheets of steel into precision edges, as well as complex automated industrial systems capable of manufacturing millions of identical pieces with millimetric accuracy, all accompanied by rigorous quality controls that eliminate even the smallest defects. So, the next time you hold one between your fingers, remember that it's not just a piece of steel, but the culmination of thousands of years of human ingenuity, constant innovation, and a fascinating process that made something as everyday as a safe and efficient shave possible.